Hello, my name is Kerem Geçer, and I'm the team leader of our project team, and this is the final video presentation of our signal generator project. Here you can see our team members. Each team member had specific responsibilities to make sure the project progressed smoothly. And based on our customer expectations, our design prioritizes four key features: portability, smartphone control, nanoseconds precision, and affordability. And we analyzed existing portable pulse generators in the market and found that many of them lack nanosecond precision, and the devices with higher accuracy are generally expensive and bulky. And signal generators currently available often suffer from key limitations. They are large, they consume too much power, most of them don't allow waveform customization, and also they lack smartphone control. And these are our key marketing and engineering requirements. For example, long battery life translates to using less than 5 watts of power and operating over 10 hours. And smartphone control is achieved through Bluetooth and Type-C. Each marketing requirement was backed by an engineering requirement and a justification. And here you can see our objective tree. We achieved our goals by selecting low-cost parts, enabling Bluetooth and Type-C connectivity, and using a precise timing circuit. We also added some technical and social constraints to guide our design choices. We designed the device within the limits of the STM32 microcontroller and a 12-volt battery system. We used affordable, widely available parts to keep it student-friendly, and the design also focuses on low power use, durability, and easy manufacturing, which makes it practical and sustainable.
Hi, I'm Utku, and I'm going to talk about our product's concept table, how we choose the concept, our level 0 design, and our use case view. Here's the concept table. We created some methods with randomly selected features to choose from here, from the table. Then we use some methods to evaluate which concept to choose. We firstly use strength and weakness analysis. We analyze the methods with their strength and weaknesses. Secondly, we use tough concept table. We graded the methods with some criterias. And we lastly choose the best features to create our concept. We choose smartphone app, smartphone display, Bluetooth Type-C, 12-volt battery, and pocket size. And that makes our final concept. The use case view, in our product, the user does everything by himself or herself, powers the device, connects to it, starts and stops the generator, also can see the output from the smartphone. The level 0 design, we give 12-volt DC input to our generator and the user creates the signal. We get the output from the generator and also we can see the output through a smartphone and the user can control the input and output through the smartphone.
Hello, I am Oğulcan. First, I'm going to talk about level 1 design. In level 1 design, we broke down the system into 6 main parts, like organs in the body. The power supply is like a heart, and the microcontroller is the brain, the pulse generator is the hand, and the Bluetooth module is the mouth and ears, and the output section is like the muscles, and finally, the user interface is the face of our system. In level 2 design, we focused on the internal details of each model. The system is powered by LiPo battery, and this power regulated by MIC and AMS voltage regulators, and the system is controlled by STM32F4 microcontroller. And for the pulse generation, we use SI5351 signal generator. And Bluetooth communication is handled by HC05 module. And the user interface includes the tactical buttons, LEDs, and little buzzers, passive buzzers. And output signals are delivered through the SMA and Type-C connectors. And we have TVS diodes for voltage protection. And we performed two main tests to check if our signal generator works as expected. In this test, we connected the device to the phone with Bluetooth, changed pulse settings from the app, and start and stop the signal, and got feedback with LEDs and the buzzer. And here we tested how accurate the pulse widths are. We used an oscilloscope to measure the signals at 5 nanoseconds to 50 nanoseconds. The results showed that the device works well within the expected range.
Hi, it's Muhammed Demirel. I'm the software engineer of this group and I'll be presenting management part of this project. Here you can see our work breakdown structure. We obtained it as level 0 and level 1. Then we separated level 1 two parts. First is design and development and the second is project management. Here you can see our Gantt chart for this project. And for cost analysis, here you can see our total cost. By using affordable components and efficient planning, hardware and software expenses stayed low. Also, we ensure quality without overspending. We analyzed how many units we need to sell to cover our costs. We found that selling around 39 units at $150 for each covers our costs. This confirms the project is financially viable with a clear break-even point. We identified key risks such as Bluetooth issues and hardware failure. Medium risks like power use, budget, and delays are managed through careful design and planning. We also verified timing accuracy with an oscilloscope. Our device follows international quality and safety standards and aims to meet lab testing and European certification requirements. Our device is portable, affordable, user-friendly, and has smartphone control with precise output. It will launch at $150 through small-scale academic and online sales. If it will be successful, we plan to grow up. Thank you for watching.